With a standard calendar invite, data moves effortlessly across the web until the attendee clicks download. Then the connection slams into a wall. Traditional .ics files are isolated artifacts. They are rigid snapshots of a schedule packed into a one-way export. The second that file lands on an attendee's local device, the organizer loses visibility. There are no read receipts, no telemetry, and no ability to update the schedule without blasting out a new email. Overcoming this limitation requires replacing the static file with a live connection. The Calendar Invite Server Stack, deployed from the AWS Marketplace, replaces this static handoff with a live architectural link. By combining simple email service for data ingress, dedicated REST APIs for processing, and an API gateway for state management, the stack establishes a bidirectional pipeline. This diagram shows the structural difference. The left side broadcast model forces organizers to relinquish control to the local machine. On the right, the Calendar Invite Server pipeline maps a closed loop. Data enters at step 1, processes through the cloud, and feeds interactions straight back to the organizer at step 6. Transitioning from static files to a closed-loop pipeline provides the structural framework necessary for the event attribution and real-time synchronization we'll be mapping out. To build this loop, we start at the starting point of the pipeline, the source calendar client. Whether operated by a human organizer or an AI browser agent, the source client executes standard create, read, update, and delete commands. That initial create command is fired off to a specific ingress vector. Inside the AWS account, you configure an SES endpoint at a custom domain, typically create@yourdomain.com. This architecture diagram maps the handoff. The source client, seen here as Node 1, pushes a JSON payload directly into Node 2, the AWS SES ingress point. Once SES intercepts that incoming command, it funnels the raw payload into the internal processing environment. This exposes Node 3, the computational core of the stack. It consists of 9 specialized REST APIs backed by dedicated Lambda functions. As the payload hits this layer, the Lambda functions disassemble the raw event data and reassemble it on the fly to match the pipeline's internal schema. Executing this disassembly at the Lambda layer ensures the system can scale compute resources, preventing processing bottlenecks when an organizer triggers a high-volume batch of event creations. With the data structurally validated, those 9 REST APIs act as the definitive routing mechanism, queuing up the events for downstream distribution. Relying on SES as a native event-driven entry point eliminates the operational overhead of standing up and maintaining custom ingress servers. The processing layer has structured the data, but the pipeline must now push those events out to the attendees. This diagram shows the central 9 API node branching outward, pushing data into 3 distinct front-end delivery vectors labeled A, B, and C. Vector A handles high-density applications. The display APIs auto-generate landing pages for complex schedules, like mapping out a full season roster for the MLB, NBA, or NFL. Vector B manages VIP batch processing. An operator can use browser-driven controls to upload a list of emails and execute bulk calendar sends to groups of 500 to 1,000 users. Vector C is the Embedded Email Service Provider, or ESP, integration, which formats the data for direct email delivery. The system generates code optimized for MailChimp, Klaviyo, and SendGrid. The organizer pastes that code into their existing email template, producing functional RSVP buttons right inside the promotional email. Separating the back-end routing APIs from the display layer ensures the internal schema remains standardized, while the system remains agnostic to the front-end delivery mechanism. To see how the pipeline closes the loop, we follow the attendee's interaction. A user opens their email or visits an auto-generated schedule page, sees an event they want to attend, and clicks a Yes RSVP button. Under the old .ics model, that local action would be stranded on the device. In this architecture, that single click initiates the return path. This diagram traces the data pathway's reversing course. Signals flow backward from the 3 endpoint vectors and converge upward into Node 5, the API gateway. The API gateway acts as the pipeline's central collection point, taking in thousands of disparate RSVP clicks and standardizing them into uniform event records. Using standard GET requests, the pipeline pulls that aggregated data from the gateway and feeds it into the original organizer's dashboard. The organizer immediately sees real-time RSVP aggregation alongside the ability to download granular, user-specific reports for every event. Connecting this return path to the API gateway creates a closed-loop platform for data visibility. Visibility is a significant step forward, but the most difficult architectural hurdle is maintaining state management across thousands of decentralized personal calendars. The Calendar Invite server solves this by enforcing a persistent, two-way tether locked between the organizer and the end user. The stack creates a sticky session, a permanent session token assigned the moment the data enters the pipeline. This system diagram highlights the connection established by the sticky session. It acts as an invisible, direct wire connecting Node 1, the source client, through the pipeline to the final end-user calendar node. This means an organizer, or their AI operator, can go back into the source data weeks after the initial invite was sent and update the event with new promotional information. Because of the sticky session, that updated payload travels down the existing tether, bypassing the standard distribution phase. It routes directly into the end user's local environment and triggers an overwrite of the existing event block. Organizers can use this capability to push out last-minute schedule shifts for a sporting event, or dynamically insert new sponsor links right before a webinar begins. Persistent attribution ensures the organizer retains authority over the event data as it exists on the attendee's device, ensuring the schedule remains synchronized across thousands of users simultaneously. By utilizing AWS infrastructure to maintain persistent sticky sessions, the calendar event functions as a dynamic, living communication channel.